Okay, so let's talk about the definitions for tonight first. We've got a couple off the bat. First of all, the word principal, when you're talking about financial math, is the starting amount. So if you've taken out a loan before, the principal is the amount of the loan on day one. Simple interest now is a type of interest that is accumulated on the original principal only. So simple interest is best for things like loans. Compound interest, on the other hand, is interest that has been accumulated on the principal, plus all of the racked up interest that has been added on over the years. So it's called compounding, and it builds. It's basically interest on interest. This type of thing is good for investments. Simple interest is better for loans for that reason. Okay, so before we start the formulas, I want to just make sure that everybody understands here what's going on. I want to make sure you understand the difference between a simple interest loan and a compound interest loan. We're just going to show it. I'm just going to show it to you through a table. So, while banks almost always pay compound interest, bonds usually pay simple interest. Suppose you invest $1,000 in a savings bond that pays simple interest of 10% per year. How much total interest would you receive in 5 years? And then, if the bond was paid in compound interest, how much would you receive? And would it be more or less? So let's take a look first. We're starting with $1,000 in either situation. This is our principal amount. And the rate is 10%. So just take a look at what happens if it's a simple interest type of account. It's 10% of the $1,000 that we invested every year, which means we would make $100 in interest each year that we left it in there. So this is what it looks like. 10% of 1,000 is 100. So you started with 1,000 in your account, and then you made $100 in interest, and now your investment is $1,100, which is fine. Then year 2 comes around. You made 10% again. It's a simple interest account, so it's only 10% of the principal only, which means you made another $100. You had $1,100 at the end of the year. You just made another $100. Now you are at $1,200. And it goes like that throughout the entire time that you leave the money in there. So if you leave it in there for 5 years, you're going to earn $100 in interest every year, which means you're going to have $1,500 at the end when it's all done, when you go to withdraw it. Does this make sense so far, everyone?
Yeah.
Okay. So that's what simple interest looks like. It'll grow by the same amount year after year. It'll build, but it will build by the same amount because it's only ever on the original principal only that it earns money on. Look at what happens if it's compound, however. For compound interest, it's 10% of the initial investment for the first year, which means you earn $100 just like in the other account. You're now at $1,100. But now when you go to start year 2, you're going to earn 10% of the new amount, which is going to be a little bit more. 10% of a higher amount is more money. And so it's going to be $1,100 from the previous year, plus the new amount, which is slightly higher, which means you're going to end with $1,210 instead at the end of year 2. Now that's what gets now that's what your interest is going to be calculated with when you start year 3. So 10% of a higher amount is a higher amount. And now you had a higher amount plus more interest, which is now growing this even faster. Then 1,331 is what you start with year 4, which earns you even more money, and that racks up even more, and it just continues to grow because you're earning interest off of your interest. And at the end of the 5 years, it's not that big of a difference. It's only about a little bit more than $100 more. but we only left it in there for 5 years. Imagine if you had this kind of setup in your 401k and you left it in there for 30 years. You would have a huge amount of money compared to the simple interest account, because that for 30 years, your simple interest account is still only earning money off of the amount you put in there on the first day 30 years ago. Okay, so that's the difference between the two accounts. They were always the same starting principal, and it was always the same rate, just two different types of accounts that we compared there. Do you guys have any questions about any of that right now? Okay, let's continue. All right, so instead of having to make a table every time you wanted to figure out how much interest did you earn or what is left in your account at the end of the 5 years, we can use formulas, and we can just plug right into them, and it'll tell us what we want instead of having to go through row by row by row and figure out what was left. So these two are the ones for simple interest. They're the only two for simple interest. So when you go through the problems, you'll be looking for the word simple somewhere in there. If you see that, it's one of these two. Now, the first one says interest equals. So this one solves for interest only. So let's go back, all the way back to the simple table. If they want to know how much interest did you make after 3 years, for example, you made $300 in interest. Right, so that's what the first formula will tell you. If they want to know how much is in the account at the end of the 3 years, for example, instead of it being 300, in the account is 1,300, the total. So the I solves for the interest, and the A stands for the total. And again, instead of having to go through a table and look at all that, you just plug it all in. So I for interest, P is the principal amount. It's here or here. Your R is the rate, but you have to change it to decimal form in both of these formulas. And then the T is the time, and that has to be in years. So even though it's rare, if it said something like it was a 48-month loan, 48 months is 4 years, you would need to change it to 4 and plug that 4 into the formula. All right, let's take a look. Oh, okay, let's do this first, and then we'll do the problem. This is the compound interest formula. And this is for pretty much any type of compounding except for continuous, which we'll talk about later. So if you see any of these words here, annually, semi-annually, quarterly, monthly, weekly, or daily compounding in the problem, that other formula, which I'll go back to here in a minute, is what you're going to use. These numbers here represent the end values in the formula, and you're not going to see anything else. You're not going to see anything where you have to plug in like 10, for example, because 10 doesn't exist. It's these numbers only. So let's go back now. So this one looks pretty complicated, but if you have your scientific calculator, all you need to do is plug it in exactly the way it's written, with parentheses around everything, and just hit enter, and it'll give you your answer. So you just need to plug in your principal, then open a set of parentheses and do 1 plus. APR is now in place of the R. It's the rate, though. And the rate has to be a decimal. And then you're going to divide it by this end value, which you'll find in the problem. You'll find one of the words in the problem. You just put it here, and you put it here, and then that thing is times Y, which is the years. Now, this is an exponent, these two things up here. So you need to hit your exponent key, and then you need to put parentheses around this up here as well for this to work. Okay, N, what is N? N is how often the bank does the calculation to figure out the interest and add it back in. So if they do the calculation once a year, that's what N is. It means that they let interest rack up from January all the way to the end of December. And then at the end of December, they calculate what the interest was, add it back in, and you start with that new amount the following January. And then it racks up, and the same thing happens at the end of the next year. If they do it semi-annually, that means they do it twice a year. So they let interest accumulate for 6 months, then they recalculate, and you start with a new amount in July, and then they let it go again, rack up, they recalculate at the end of December, and you start with a new amount then in the beginning of January of the following year. Quarterly is done 4 times a year, so every 3 months. Monthly, they figure out what your new interest is at the end of every month and add it back in. Weekly is at the end of every week, and daily is every day. So now let's take a look at this question, and I'm going to pick it apart piece by piece for you and kind of talk you through what I'm hearing and what I see and how I set this up. So you invest $800 in an account that pays simple interest. Right there, oops, sorry about that. Right there, it's telling me I need to narrow this thing down to one of those 2 formulas that deal with simple interest. It's either going to be the I equals the PRT or the P times 1 plus the rate and the time. So here's what I'm talking about. When it's simple interest, it's got to be one of these 2. It has to be. These are the only 2 simple interest formulas. We'll narrow it down as we continue through the problem, and we'll figure out which one we're going to pick. Okay, so simple interest of 4% for 5 years. Calculate the amount of interest. That just narrowed it down to the one that says I equals then. So the first thing I'm going to do is jot down I equals PRT. I'm going to take this one here. They asked for interest. So I'm going to write this down, and then I'm going to go through and try to find the 3 variables that I need so that I can plug it in and solve it. Okay, so if it's PRT, first I need the principal. The principal is the starting amount, so that's the 800. Then I need the rate. The rate is the percentage, but I need it in decimal form. So the 4% is going to be converted to 0.04. And then I need the time. The time is 5. So I can just plug that in because it's already in years. All right, so here's my process. I saw simple interest. That narrowed it down to those 2 formulas. Then they asked me to calculate the amount of interest. So then this one's out. I'm going to use that one. I jotted it down, and then I went through and found each of the amounts to substitute into this formula. And now all I have to do is plug this all in and multiply it together. All right, so 800 times 0.04 times 5 gave me 160. And that's it. Any questions? So far, so good? Okay. All right, here's another one then. Use the compound interest formula. So they're telling you which one they want you to use. And determine the accumulated balance after the stated period. The accumulated balance is the total amount in the account. And that's anything that says 8 equals is an accumulated balance. So I'm going to jot the formula down real quick. And then we're going to try to substitute this in. So it's a $1,200 deposit. APR is 2%. Quarterly compounding. And 2 years. All right. So here's the formula for compound interest. Now I'm going to start with the P. P is the principal. That's the $1,200 that is being invested. Now I need the APR in decimal form, so 2% in decimal form is 0.02. I'm going to plug that out here, divided by the N. Now the N comes from the word that you see in the problem. There'll be one word in the problem talking about how often it's compounded. So if it's quarterly, that means that N is 4. So I'm going to plug in 4 here and up here. And then the time was for 2 years, so the Y is 2. Okay, is everybody with me?
Yep.
Okay. That is challenge number 1. If you can follow everything that I'm doing here, you'll be in good shape. Now, this is times. Make sure that doesn't look like a decimal. Okay, now to plug it into your calculator, that can be a little bit challenging as well. This is probably going to take a few problems for this to really click. There's a learning curve to this, but once it clicks, it will click and you'll get it. So again, I only have my phone here, so I'm going to try to see if I can zoom it in up here. Looks like it'll display. So, okay. So here we go. I'm going to start with 1,200. Then I'm going to hit the parentheses. Then it's 1 plus. And now this part right here is division. So I'm going to do 0.02 divided by 4. And then I'm going to close my parentheses. And now I need to go up into this exponent. So on my calculator, I have a YX button. You can't see that. Or an XY button. I have that button for my exponent, but most of you guys, if you have a regular calculator there, you're going to want to look for a key that looks like that. That's called a caret, and that is going to stick you up into the exponent. So I'm gonna press my XY button here, and you'll see it put me up top now in that exponent spot. Open a new set of parentheses, and then it's going to be 4 times 2. Close, and it already displayed that if it doesn't hit equal. So
I got it right.
Yay! If you got 1248, round it off to 1248 and 85 cents. That's the answer. Let's go back. It doesn't ask this, but it will in the homework. So this is the amount in the account altogether, including the interest. You put 1,200 in, and you made some money on interest, and now this is what's in the account. This is the total. What if they asked you just for interest, though? This one is just, this is the total. There is no formula for compound interest that says I equals. You can't use the simple one because that's for simple accounts. So if you're asked for interest on a compound account, You still have to go through this whole formula, plug it all in, figure out what is your total, and then to find the interest, subtract what you ended with minus what you started with. That's the principal is what you started with. The difference is interest. If you put $1,200 in and then it made interest, it made $48.85 worth of interest, and then you ended up with this as a total. So if they ask you for interest on a compound account, that is how you do it. Don't use the simple interest formula. It will not work. That's only for simple accounts.
Okay, subtract what you got from what was in the account.
Yep. Total minus the principal. The total from the compound formula minus the principal, which has to be told to you to even do the problem. And then the difference will be the amount of interest if they ask you for that. All right, so here's a new formula. This one here, if you notice, this one's got the P on the end of it now. This one is the only one that solves for present value. So what you're going to be looking for in the questions for this formula is it'll say something like, how much needs to be deposited today, or how much needs to be in the account right now, or some sort of synonym for the present. If you see that, that's when you use this one. Everything about this one is the same, except for the fact that instead of multiplying by P, you're taking the A, which is the future value, and dividing it by all of this other stuff. So let's take a look at this, at an example that uses this formula. So how much money should be deposited in an account today? That's the word that's telling me everything. That's the one that's telling me I need the one that says P equals. And then I'm just jotting the formula down real quick. Then I'm going to substitute it in just like I've been doing and see what it comes out to be. So my future value now is A. That's the 10,000. That's what I want it to be 8 years from now. My APR is 6%. So that's going to be 0.06 when I go to plug it in. It's compounded weekly. Weekly compounding means that N is 52. And the time is 8 years. Okay, so again, here I chose the formula because it asked for how much today. And then I'm going to substitute into this. 10,000 is what I want it to be 8 years from now, so that's my future value. 1 plus my APR is 0.06. My N is 52 because it's weekly compounding. And then I'm multiplying that by 8 years. And that should tell me how much I need to put in today. All right, so now we're going to just try to plug it in again. And we'll see if we can all get it to come out right. It's going to be 10,000 divided by, make sure you use the parentheses around everything that the formula has it as. I got 61, 89, and 55 cents. Better. There's me. That's how I plugged it in. Make sure it's 10,000 divided by, and then open up the parentheses and plug it all in just like the other problem. All right, now think about this before we go to this next one here. If you want to put money in an account today and let it grow, it should be less. You put in about $6,200 and leave it in there for 8 years. It will grow to about 10,000. That's a reasonable amount. If you use the wrong formula, which is often what people do and mess this problem up, you would get something higher. You would get something like 14,000. Why would you put $14,000 in an account and let it grow to 10? That does not make sense. You lost money on that. So that is an indication that you used the wrong formula or you plugged it in wrong. You want this present value amount to be less than what it's going to grow to. Okay, now this is just another one. I want to get to the next formula. It looks like we're doing pretty good. All right, so here is the next formula. It's called annual percentage yield, which is also known as effective yield, which then people in the banking industry sort of shorten to yield, but anyway, it's a yield somewhere in there, and it's the only one that has a Y. Okay, and basically, this is what it means. I'm going to try to explain this in plain English the best that I can. A few years back, what banks used to do is they would advertise interest rates as whatever. Let's say it was a 5% interest rate. But what they wouldn't tell you was the compounding. So you might go into a bank thinking that you're going to get a 5% interest rate, but the compounding is, let's say, daily compounding, which would make that interest jump up. It's going to grow and grow and grow really quickly if it's recalculated at the end of every day. And then maybe the bank across the street, if you're trying to shop around, has a 4.9% interest rate that they're advertising, but their compounding is only annual and it's only done once a year. The 4.9 interest rate with a compound period of 1 might actually cost less, or it might be a better rate than a 5% rate that's got daily compounding. So in other words, they weren't telling people the fine print behind all of that, and it was very difficult for people to shop around. So now this is annual percentage yield. Here's what it means. What this formula does is it takes a rate and the compounding and changes it into what it would be if it were annual compounding. So if it's daily compounding, it'll change it to an annual rate. If it's weekly compounding, it'll change it to an annual amount. Monthly compounding changes it to an annual amount. And that way, if you shop around, you can compare apples to apples because everything would just be the same. Everything would be annual compounding, and it changes the rate to what it would be equivalent to then. Okay, here is the formula for it. It's the only one that has the Y. So Y for yield, and all you need is the stated rate and the compounding periods. And what it's going to do is, like I said, it'll change that rate, take out the compounding, and give you a real rate, what it would be equivalent to if it was done once a year. Okay, what you will have to do at the end of this, though, is multiply it by 100 because we want to change this back to percentage form. So here is an example. The bank is offering 3.25%, but it's compounded quarterly. So the quarterly compounding is the fine print. We're going to get rid of that and see what the rate would be equivalent to then. So APR is 3.25 with quarterly compounding. All right, so going back to my formula, I'm just going to jot this down and then substitute it all in. And then we'll talk about how to plug it all in. So here we go. All right, so my APR is 3.25%. So in decimal form, it's 0.0325 over N. N is quarterly, so N is 4 here and here. And then we're going to just subtract 1 off of that. And then when we're done with that, we're going to get a decimal, and then we'll hit times 100, and that'll change it to percent form. So let's try it, and let's see what you get. So open up parentheses, then 1 plus 0.0325 divided by 4, close the parentheses, hit your exponent key, and put a 4 in. And then, let's see here, then you got to arrow down and make sure that you hit the -1 after the fact. If you're having trouble, here's my suggestion. Hit equal right here, then do whatever your answer is. Then do -1 if you're having any trouble. All right, here's the decimal I got. I just jotted the whole thing down just to show you. And then when you're done, just leave this in the calculator, hit times 100, and that'll give you your percent. And then you can round it off. So I would make it about 3.29. That's what I'm getting as my final answer. So let me do another one. Okay, here's another one. Same formula. Let's see how we do. Here's what I got. And that's after I did that. So a couple things I just wanted to mention before we wrap this up, or this section up. If look at the answer that we got, 2.43. The advertised rate that the bank was displaying was 2.4. But with the monthly compounding, it's more like a 2.43% rate. That's what that formula does. It takes the compounding out of the equation and turns it into an annual rate, so then you can compare it bank to bank. All right. This is the last one for this section, and then we'll see how you guys feel. All right, so this one here, we're going to go all the way back. And now this is another compound interest formula, but this is for continuous compounding. So I'm going to bring this old one back up that we had been working with before and show you why we need a new one. And then I'll explain what that E thing is if you've never seen that before. Okay, so here we go. Here's the old one that's been working for everything so far up until now. This is the formula that you use for compound interest if it's pretty much anything at all except for continuous. So if it's annual, quarterly, monthly, daily, anything, this formula works for all of those. The problem is if it's continuous, continuous means infinity. It never stops. The computer is calculating this interest every trillionth of a second and just cycling it through so fast that it looks like it's just doing this calculation forever, literally forever. And obviously, there's no way to plug in an infinity sign in for n in this formula. So what they did instead, and this is all the math background and all this you don't need to know, but what they did is they plugged in values for n that were super huge. Like, what would happen if n was like 1 billion? What would happen if n was 1 trillion? And they took a look at it on a graph. And basically, that's where this thing came from. On a graph, these lines start to go towards this thing here. It's called E. E is just like pi. E is not a variable. It's an irrational number. And there is a button that we're going to look for on the calculator that will do this all for us. So look for your E to the X button. You'll probably have an E key, and you're going to have an EX key. You want the one with the X. On this little app that I'm using, my EX key is above my LN, which is where most of them are. If you see your LN key, you'll probably see an EX above it. And that means I just have to hit Shift, then I have to hit that button to use it. Okay, so let's take a look at an example, and I'll show you how to plug this all in now. So you're depositing $100 in an account with an APR of 8%, and it's continuous compounding. How much after 15 years? So A equals P is 100 times, we're going to use our EX key, which is automatically going to put us up into the exponent, and then it's going to be 0.08 for the rate times 15 for the time. So it looks like, once it's plugged in, it looks like this. What's going on here? That's straight, that's crooked. There we go. There we go. All right, so here's how you're plugging it in. Here's your P. Hit times, then find your EX key, and that'll automatically put you up here. And then just plug in your APR times the years, close, and hit equal. I'll tell you what I get so you can check yourself. I got 332 and about 1 cent. 332.01.